9.2, which is logarithmic equations, solving them. So there are a few important things you need to know about logarithmic equations. A logarithmic equation is an equation that contains one or more logarithms. So it has to have an equal sign and a logarithm in it. So a common logarithm is a logarithm that has an implied base of 10. So if they don't write the base in, we know the base is an implied 10. We learned about that yesterday. An extraneous solution is a solution that you get when you solve an equation, but it doesn't actually work when you go to plug it back in. So there's a few different types of extraneous solutions that you need to understand for specifically logarithmic equations. The first type is if you're ever taking the log of something negative, you automatically know that that is rejected. We cannot do it, okay? Also the log of 0. The reason for this is we know that this right here represents the answer. You can never put something to a power and it will ever result in a negative number. It's not possible. So that's the reason why this number in specific can't be negative. The base can be negative and the exponent can end up being negative, but the result of that solution cannot be negative, okay? And it also cannot be 0 because you can't take the log of 0 because you can never put something to a power that will result in an answer of 0. So those two things would be yield us a no solution, okay? So those are the main two that you really need to worry about. All right, so step 1, we're going to learn or practice how to rewrite these so that we can do them in other ways that don't involve logs. We can write them as exponentials. So on these questions here, we're going to rewrite these log equations as exponential equations. So how could I rewrite this as an exponential equation? It would be 16 to the power of, good, 5 over 2 is equal to x. So you remember this from yesterday? Now in this case, you can just actually find out what x is by doing 16 to the 5/2 power. So in your calculator, you're going to type in 16. You're going to hit the little upside down V, the caret button. Left parenthesis, 5 divided by 2. And then close the parenthesis and then hit equals. And if you did it right, you get 1024. So just make sure you have to put it to the power of and you put those in parentheses. That's going to be the key to getting this question right. Additionally, a few other things to mention here. If you wanted to verify that you did this correctly, you could just kind of go through and plug it back in again into the equation. All right. So the next one, how could we rewrite this in exponential form? X to the, good, to the power of 3 over 2 is equal to? Good, 27. So here's the problem. We can't put x to the power of 3 over 2 in the calculator, so we have to use a reciprocal method. So here's how it works. This is where if you put one side to the reciprocal of that exponent, what's going to happen when you multiply 3/2 by 2/3? And it becomes what? 1. Now if I do that, that's great, it gets rid of it, but on the other side I have to do the same thing to balance the equation. So that's how you can do that when you have some variable to a power. You can put both sides to the reciprocal power. This cancels this out and leaves you with x equals. Now in here, to do this in the calculator, you do 27 and then caret parenthesis 3 divided by 2, close the parenthesis, and you should get 9 as your answer. Okay? You can verify this by doing 9 to the 3/2 power, and it should come out to be 27. So you can always verify your work to make sure it works. That's what's really cool about this section. Everything can be verified. Everything can be verified. All right, next one. How can we rewrite C exponentially? 2 to x, just regular x, is equal to 1/64. So in this case, we're going to have to use our logic here. So we know that we can rewrite 64, or 1/64 as 64 to the -1 power. Now, I'm just going to write it up here. We know that we can rewrite 64 as 2 to the 6th, right? So 2 to the negative 6 power is the same thing as 1 over 64, right? So what do we know we can do when we have the same base? Yeah, we can just set the exponents equal and we get x equals negative 6. So that's like yesterday's stuff. Now there is a way to do this in the calculator, which we're going to learn about on the next slide. Alright, we got one more to try. So this is x to the power of, good, is equal to 1 over 125. So we can use reciprocal power on this one, right? Isn't negative 3 the same thing as negative 3 over 1? And then what would be the reciprocal of negative 3 over 1? Negative 1/3. If you put both sides to the power of negative 1/3, that cancels this out and leaves me with x equals. So in your calculator, you do 1 divided by 125 equals. And then you hit the caret button, and you do parenthesis, negative 1 divided by 3, close the parenthesis. And if you did it right, you should get 5. Which kind of makes sense, right? Because 5 to the negative 3 power is the same thing as 1 over 5 to the third, which is 1 over 25. So you can logic your way through and make sure that it makes sense. Alright, cool. So now that we've addressed that, now we're going to talk about logarithmic equations and the important parts of how to solve these. So, when you go to solve a logarithmic equation, you have to verify that the bases are the same, okay? If the bases are not the same, you cannot do this step, okay? So if they're not the same, you cannot proceed like this. Once you've verified the bases are the same, you can actually set what the logs are of equal to each other, just like with the exponentials. So we're going to set what the logs are of equal to each other because they have the same base. Now from here, in order to solve for x mathematically, we have an x squared, we have a constant, and we have an x term, a linear term. What am I going to have to do to solve this? So we can't square root when we know we have a plain x here. That would only work if we had a constant and an x squared. We're going to have to get everything to one side and then do what? Yeah. So if I bring everything to one side of the equation, I now have something, I have a quadratic or a trinomial that can be factored, right? So we can factor this into two binomials. So we know that it can factor into two binomials. So we're looking for factors of negative 15 that would add up to negative 2. Good. Negative 3, positive 3 and negative 5, right? Does everybody understand why the 3 had to be positive and why the 5 had to be negative? Okay. So then we set these each equal to 0 and we get, x equals negative 3 and x equals 5. Now these are potential solutions. Okay, we don't know for sure if these are the actual solutions yet. In order to verify that, we have to plug them back into the original. So, I'm going to start by looking at the negative 3. If I plug negative 3 in here and here, what is negative 3 squared going to be? 9. What's 9 minus 15 going to be? Yeah. Can you take the log of a negative? What did we talk about in the last slide? We can't do that, right? So for that reason, because when we plug in negative 3, it gives me something negative inside the log, the solution actually gets rejected, okay? Because it produced a negative inside of the log, you cannot have negatives or zeros. It always has to be greater than 0. So let's try the 5. What is 5 squared? Minus 15? 10. What's 2 times 5? So we got log base 3 of 10 is equal to log base 3 of 10. That's true, right? And there's no negatives in there, or zeros, so this one's good to go. So our true solution is just 5. So when you have one solution or two, you just write it in these curly brackets. So that's verifying the solutions. Is everybody good with that? Okay. Let's try another one. First thing we want to do is verify that the base is the same. once we know the base is the same, we can set the inside of the logs equal to each other. And then we can just bring everything to one side of the equation. And then lastly, I'm going to add the 10 over. Alright. Now I'm looking for factors of 10 that add up to -7. Good. -2 and -5 would add up to -7, but would multiply and give me 10, -10. So what would be my two potential solutions?
5 and 2.
Good. So you're setting these equal to 0 and then just solving for x. So that's what you would end up with. And then from here, you want to plug these back in to verify them. So I'm going to start with the 2 first. What is 2 squared going to be? 4. What's -4 times 2 going to be? -8. What's 4 minus -8?
-4.
What's the problem with that?
Negative.
So this is not a solution because it yields me something negative inside the log. So I don't need to check the other side to see if they're equal because it's already ruled out. You don't have to do more work than necessary. Okay. Now for the next one, what's 5 squared?
24.
Good. Minus -4 times 5, so minus 20. So 25 minus 20 is?
5.
Good. Over here we get 15 minus 10, which is? So both sides equal the same thing. Neither of those numbers is negative or 0. So this one is a confirmed solution. So do we have any questions about that? Okay. All right. So we have something called the change of base formula. And this allows us to put logarithmic equations in the calculator that have a base other than 10. So in your calculator, when you use that log button, it's assuming that the base in that log is 10. So we have a change of base formula which allows us to adjust the base accordingly. So here's how we use it and the reason why. So first I want to show you why we would use it. So what is the implied base of this log right here?
10.
Good. This is log base 10 of 5. And we learned yesterday we can set it equal to some variable, right? And then we could solve it or rewrite it in exponential form. 10 to the x is equal to 5. Now here's the dilemma. Can you think of any way to rewrite 10 or 5 that has the same base?
5 times 2.
It has to be exponents. So unfortunately that just isn't possible. There's no way to work our way around figuring out what power I can put 10 to that's going to give me 5. So this is where we use the log and the calculator to help us figure this out. Okay? So if it's not something simple like x to the 10 or 10 to the x is equal to 100 where we can think about it, here's where we use the calculator. So here's how you do it. We have all confirmed that this is log base 10 of 5, right? So here's how you do the math. It's going to be log of whatever it's of over log of the base. So base is bottom, B for bottom, okay? The base goes in the bottom. And if you do this in your calculator correctly, you're going to get the answer to what x should be approximately. And all the time, unless otherwise specified, we're going to round to the nearest 10 thousandths, which is 4 decimal places. So in your calculator, you're going to hit the LOG button. You're going to type in 5, close the parentheses. You're going to hit the division sign, hit the log button again, and then hit 10, close the parentheses. And when you hit enter, you should get something 0.69. And then it's 89, so the 9 is going to round up to a 10, so it's going to be 6990. So I will say, if you guys are struggling with rounding at this stage in the game, there's a lot of good videos on YouTube that talk about rounding, because we just won't have the time to address it in this class in depth. So if you guys have any questions or struggles with that, there's really good resources online to help you out. So what that means is, mathematically, if you take 10 and put it to this power, you're going to get approximately 5. So we just figured out what we can put 10 to get 5. That's the reason for why we would do all of this. Okay? All right. So let's go ahead and do the next one. What is the base on this one? Good. So how are we going to type it into our calculator? Mm-hmm.
0.5.
Yep. Good. So in your calculator, you're going to hit log of 0.5, close the parenthesis, divided by log of 10, close the parenthesis. And you should get, what'd you guys get? Negative. So for anybody who's wondering, well, what about, you said no negatives. I didn't say no negatives completely. This right here tells me what the exponent would be. Exponents can be negative. The result of exponents is what cannot be negative. So just be careful about understanding. You can put something in the log and it can produce a negative number. Just like I can put 4 to a negative power. 4 to the negative 1 is 1/4. It doesn't produce a negative answer. Okay, that's the difference between those two scenarios. All right. And then I do want to show you something else real quick. What if you just in the calculator do log of 0.5? Just log of 0.5. What do you get when you do log of just 0.5?
Should be the same.
It's the same. That's because in your so the calculator implies the base of 10. So if the base is already 10, you technically don't need to divide by base 10. What I want you to do in the calculator now, what is log of 10 if you just do log of 10? 1. Because the base, anything to the first power, anything to the first power is itself. Okay, so that's the reason why that works. Okay, so for that reason, if it is a base of 10, you don't have to divide by the 10. But I just showed you that way in case you forget the procedure. You just follow the same procedure every time. All right. So the next one, letter C. How could I rewrite this one?
4x is equal to 23.
Oh, you're right, but in like the... Yeah.
23 over log.
Good.
Yeah.
Yep, log of 23 over log of 4. So this one you don't have a choice but to divide by the log 4 because it's not the common base. So log 23 divided by log 4. You should get 2.2618. So remember, 4 decimal places is typically what you use. Okay? All right. Next one. How are we going to do this one? Log of 8 over log of 6. And this is 1.1606. All right, so now that you're good with the log operations, we're going to talk about how to solve equations using this method. So, here's what we do. I don't know what number I can put 3 to the power of that's going to give me 15, so this is where logs come into play. Whenever you're looking for a missing exponent, that's what logs are useful for. So we learned yesterday how we can rewrite this as a logarithmic equation, right? How can we convert this exponential to a logarithmic? It's going to be log base 3 of good equals x. So this is from your 9.1 notes. How to convert exponential to logarithmic. Okay, that's how I did that. Okay, so if you were absent yesterday, that's why you might be confused by that. So now that we've converted it, how can I rewrite this in a way that I can put it in the calculator? Log of 15 over log of 3. So this right here is the exact solution. But if I want to find an approximate solution, I can put it in the calculator. So log 15 divided by log of 3. And you should get approximately 2.426 50. So what that means is you can verify that this is correct by taking 3 and putting it to the power of that number. So in your calculator, if you want to test that out, go ahead and do 3 to the power of 2.4650. And it should give you approximately 15. That's what we just found using logs. Okay. All right, so now I'm not going to do the calculator one on this one. I'm just going to set it up because you guys are probably good with that. So how can we rewrite this as a logarithmic equation? Log base 16 of 42 equals x, right? So how can I now rewrite this for my calculator? Log of 42 over log of 6. And then you can put this in the calculator, get an approximation. I'm not going to do that because you guys are probably pretty good with it. All right, so these two are a little bit different. So notice this one. If I rewrite it as a logarithmic equation, just from your 9.1 notes, the base of is equal to the power. I know that I can rewrite this side as log of 8.25 over log of 2.1. And then what can I do to get this 2 to the other side to get the a by itself? Yeah, minus it. So just be careful. When you subtract this 2 over, just make sure you don't put it in the top or bottom of this fraction. It's on the outside of it, okay? So if you're going to do this in the calculator, you do this step first. Then you take that answer and subtract 2 from it. So a is approximately equal to, so log of 8.25 divided by log of 2.1 minus 2. So my answer is approximately 0.8442. All right. Next one, this would be log base 7 of 20.42 is equal to x squared. This can be rewritten as log of 20.42 over log of 7 equals x squared. How do I get rid of x squared? Square root both sides. So the best way to do this mathematically to approximate is to do this all in one step. So that's a little bit important. We got to talk about that. So in your calculator, clear it out. Do you guys see where it says x squared all the way on the left, like towards the middle? It says x to the second power. If you hit second that button, you should get a square root. Once you have that, you can hit log of 20.42, close the parenthesis, divided by log 7. Now when you close the parenthesis here, you have to close it once and then twice for the root. And if you do it correctly, you should get about 1.2451. All right. And then the last one, while I pass out homework, go ahead and give the word problem a try. It's just plugging stuff in, okay? Bless you.